Welcome to 4.2, the unit circle. So this will be the last lesson to do with 4.2. You'll notice which pages in the textbook it goes with. And let me just get my pen started here. Okay, so the unit circle, once again, is a circle with radius 1 and it's centered at the origin. So this would be at the 1 spot here, and for the y value that'd be 1 as well. The equation for the unit circle is x squared plus y squared is equal to 1. So you can think of the circle as all the ordered pairs, x and y, that satisfy that equation. So for example, if x was 1, then y would have to be 0, and that's this spot here. If x was 0, then y could be positive 1 or it could be negative 1. So you get those, often you get two answers, right? So x comma y is the set of values of x and y so that x squared plus y squared is equal to 1. It's not a function, is it? Because it doesn't pass the vertical line test because you're going to have two values of x often. Moving down. This is the notation that we use. So in this case, we're going to pick a point. We're going to call that point P. And theta in this case, P of theta, is the amount of arc rotation. Okay, so this is the amount of this arc in theta. It can also mean, if we join this line here, and I'll try to join it, there we go. It can also mean this theta in a more familiar sense of what's the angle here. And what's cool is this theta in radians is the same as this arc length. Why is that? If we think about our S is equal to R times theta, right? This is my arc length. This is the S value here, right? Theta is the amount of rotation in radians, and in the unit circle, R is equal to 1. So this we can label as theta is the amount of the arc length or as the amount of rotation. Kind of cool. So P of theta, so I'll put the theta in here, is going to be equal to x comma y, some point x and some point y. Now let's just think about for a second way back when you learned SOH CA TOA as a definition for sine, cos, and tan. Just as a reminder, S, that's the sine, right, of some angle theta was equal to the opposite over hypotenuse, and the cos of theta was equal to the adjacent side over the hypotenuse. And a pretty good working definition of what sine, cos, and tan are. I think we're going to see now with our unit circle, we can enrich that understanding just a little bit. I'm going to erase some of this stuff just so that it doesn't get too complicated here. If I draw this triangle here, and just a quick note, whenever we're drawing triangles from an angle, we should always draw what we call bow tie angles. So here I'm going to say draw bow tie angles because bow ties are cool. No, not just because of that. For example, any time that you have an angle, say if it even goes up over here, right, and you're thinking about making a triangle to figure out sides and things like that, we're going to do that today. I want you to draw it off of the x-axis. So draw a line to the x-axis. So here are all the different types of bow tie angles. And it kind of makes a bow tie, doesn't it? In fact, it looks a bit more like a butterfly. Okay, we could also say draw bow tie angles or butterfly angles. So again, whenever you have an angle, then you draw there. You're going to make a triangle that has a side common with the x-axis. Don't draw it with the y. Okay, so in any case, so this is P, and this has an x and a y value. So this would be the x value. This side is of length x, and this is where the y would go. This is the side y, right? So if we're thinking about this angle here, and we say, okay, sine is equal to the opposite side over the hypotenuse. Well, in the unit circle, the opposite side is what the y value is. And the hypotenuse, that's this side. Well, in the unit circle, this radius is always 1. So this is what's kind of cool. I'll try to make my y larger. This is what's kind of cool about the unit circle, is that instead of using SOH CA TOA, you can say the sine of an angle is equal to the y value on our unit circle. So, put a big asterisk down over here. So is equal to the y value. Exclamation mark. And how about for cos? Cos is going to be equal to the adjacent over the hypotenuse. So that's going to be x over 1. So that's going to be equal to the x value. So if I said, what are the x and y values for some angle on a unit circle? It would be exactly the same as saying, well, the cos of the angle and the sine of the angle. And in fact, this is a better explanation than SOHCAHTOA, because what happens when we take P and we move it over to the second quadrant? What happens if we pick another point over here? So instead of P, let's call it Q, all right, just for another point's name. For our Q value here, so I'll go up here, and I'll draw my bow tie angle down over there, okay? So what's different now is my X value is going to be negative. My Y value will still be positive because I'm in quadrant number 2. My x value is negative and my y value is positive. It's a bit hard in opposite over hypotenuse to think of how can I have a value that's negative. But when you start thinking about the unit circle, it kind of makes sense that you can have an x value which is negative and a y value which is positive in the second quadrant. So the unit circle is extra helpful that way. So the important ideas for this lesson is that if P is any point on the unit circle, right, then we could say that there is an ordered pair x comma y so that it satisfies this. So it satisfies x squared plus y squared equals 1. And another way to think of this is that this x is the same as the cos of the angle and the same as y is the same as the sine of the angle. Now since x squared plus y squared equals 1, so that's Pythagoras, which you've known since forever. This is cool. This is a quick little trig identity that we're going to be learning later on. We're going to be using later on. It's the key to so many things, is that cos squared plus sine squared equals 1, just because x is equal to cos and y is equal to sine. So this is for a little bit later in the course, but we're just introducing it to you today. Okay, moving on to the next page, we can start answering a few questions here. It says there's a point 2, 3, 2/3, comma y is on the unit circle. Find the value of y. Well, before we start the question, why don't we just kind of visualize it? I'll try to draw a unit circle here. Okay, so just a reminder, so this would be 1, 0, because the radius is equal to 1. So if x was 2/3, 2/3 of that would be somewhere around here. And so my point could be, this could be a point, right? So this could be an x value of 2/3 and some y value that I don't know. Is there any other point that would also have an x value of 2/3? I'm giving you a pretty good hint. Yes, down here would also give us a value, right? Where the x is 2/3 and we get some kind of y value. This one's going to be a positive y value and this one's going to be a negative y value. So these are our 2 points that we could have. There's one. I'm just drawing the triangles. There's the other one. Now you'll remember that the formula for the unit circle is x squared plus y squared is equal to 1. In this case, we know what x is. It's 2/3. 2/3 all squared plus y squared is equal to 1. 2/3 is 4/9 plus y squared is equal to 1. So I'm subtract 4/9 from each side. So y squared is equal to 1 minus 4/9. To subtract fractions, I need to have the denominators the same. So 1 is the same thing as 9/9. 9/9 minus 4/9 is equal to, it's still y squared. So y squared is going to be equal to 5/9. And we'll square root both sides. So I find out what y is. So then y is equal to, when I square root a fraction, it's the same thing as the numerator, the square root of the numerator, divided by the square root of the denominator. Now, when I'm doing this square root here, I can get both positive or negative values, okay? And most of the times we say in math, the principal square root is positive. Here is an example where I'm anticipating ahead of time I'm going to get a positive value and a negative value. So I'm going to put plus or minus, right? Really what that means is y is equal to, there's 2 answers. Y is equal to positive root 5/3 and y is equal to negative root 5/3. There's these 2 answers, and those are our 2 points. So really it shouldn't say find the value, should it? Maybe it should, or find the values. Okay, we could fix it that way too. Find the values of y, because there are two values for this case. Oh, and there it is. There are two possible values for y, since there are 2 points on the unit circle that share the coordinate x equals 2/3. Second one here, it says, determine whether or not 2/5, 3/5 is on the unit circle. Justify your reasoning. Okay, well, we're going to start off the same thing, and we're going to say the equation. And if justify means it's kind of like an explain. We have to use some words. So justify your reasoning. We're going to use some words in our answer. We're going to say the equation of the unit circle is x squared plus y squared equals 1. So we're going to test whether or not 2/5 squared plus 3/5 squared is equal to 1. So I'm going to test that. So I'm going to put a little question mark over there. I'm not sure yet. I have to do the math. It's a little tricky because it's deceiving, isn't it? 2/5 plus 3/5 is equal to 1, but what happens if we square it? So 2/5 is 4/25, right? Because I have to square the 2 and square the 5, plus 9/25 is equal to, I wonder, is it equal to 1? I got that question mark over top, so it's going to be 13/25 is not equal to 1, right? So one more little bit of writing just to, to justify the answer. I could say 2/5, right over here. I could say 2/5, 3/5. This ordered pair is not on the unit circle. Maybe because, short for because, 2/5 squared plus 3/5 squared is not equal to 1. You could say it that way, or it does not satisfy x squared plus y squared equals 1. Another way to write it. That's enough English to justify your reasoning. Okay, we have this last page to do. I'm just going to tell you ahead of time, we're not going to do example number 5. And you can go to the bottom, and we're going to save this part for later. And if you haven't done already on this 4.2, we're going to do questions 2 through 6. So, I haven't really been keeping track of exactly which pages I've assigned. So we don't have to worry about question number 1, but the other ones up to 6 we should do. All right, so let's go back up. Similar triangles. What are similar triangles? I think you took them perhaps even in grade 9. I'm not sure. Similar triangles are a pair of triangles, or even more than a pair of triangles, where they have the same shape. So you're going to have, like, say, one triangle that looks like this, and then you could have another triangle. I didn't do a very good job. That looks more like pumpkin, jack-o'-lantern eyes or something. But anyways, we're supposed to have two triangles that have the same shape, and what you learn from this is that the corresponding angles are equal, and the corresponding sides are proportional. And if you're like, oh, what does proportional mean again? You know what? Just relax. We'll do the example and it'll all become clear. At least I hope so. So we have a point p theta. It lies on the intersection of the unit circle and a line joining the origin to the point 4,3. All right, so we're gonna see this type of question a fair bit. So let's just visualize it right now. You don't have to draw a diagram every single time, but it is kind of nice. Okay, so here is our unit circle. And remember, the unit circle is only 1 by 1. The x value, this only goes up to 1. So we need to say there is a point p theta. It lies on the intersection of the unit circle and a line joining the origin. So here we go, origin with some point over here. So this is 4,3. Right, if I drew this line, if I extend this line out, and if I extend that line out here, right, this would be where x is 4, right, and this would be where y is 3, and clearly it's bigger, it's outside of the unit circle. Where's the point? I think it's time for some green here. Where's the point, or what's the point? It's p theta is right there. Okay, there's my p theta. That's the point there. Find the coordinates. In other words, what we're asked to do is find p theta is equal to x comma y. We're supposed to figure out what's this x value and what's the y value. Okay, so I'm thinking right now you can look at this and you can see where the similar triangles are happening. So the similar triangles are going to be this triangle here. If I remember, I've got to draw it straight down. Okay, so there is one triangle, and then here is my other triangle, right? In fact, they have this common theta angle inside of it. So my two similar triangles, and I'm going to call this method number 1, is our looking at similar triangles. Okay, so we'll have there we go. So this side is 1. This side of our triangle is going to be whatever our x value is, right? We need to find out what x and y is at this point. P theta is equal to x comma y, and this is our x value, so here is our x and there is our y. Okay, drew that triangle kind of small and is similar to the big triangle here. So if I draw the big triangle, kind of going downhill here. So all right, so this side is the x value is 4. And this is the y value 3, right? Because over here it says 4 comma 3. So this side, that's 4, and this side would be 3 long. Okay, so the first thing I need to do all the time is find the hypotenuse. Hey, it's a 3, 4, 5 triangle. 3 squared plus 4 squared equals 5 squared. Taking for granted that you remember how to do that quick one. Okay, so now we can do the corresponding sides are proportional. Now here's what we're going to do. We're going to say if we pick x over 1. So now we need to do is pick the corresponding sides and make that same proportion, make that same ratio, I should say. X over 1 is equal to 4 over 5, 4 over 5. Boom, done, right? So therefore x is equal to 4/5. Okay, can we do a similar one with y? Now don't pick y over x because that's not helpful. Why don't we pick y over 1? So over here we'll say y over 1 is equal to 3 over 5. So boom, we're done. Y is equal to 3 over 5. So we have our answer. So we should, since it's an ordered pair, we should say 4 over 5, comma 3 over 5. There's our answer. Nice. Okay. Now that was method number 1. Let me give you a method number 2, and let's go for blue on this one. So we'll say method number 2. Method number 2 is the fact that I just told you a second ago that your x value is equal to the cos of theta on the unit circle. So on this unit circle, whatever the cos of this angle is the same thing as the cos of this angle, because on similar triangles, the corresponding angles are equal. So if this angle is equal to that angle, the cos of this angle is the same thing as the cos of that angle. And x is equal to the cos of that angle. So cos is equal to adjacent. Okay, I'll put my SOHCAHTOE up here just in case you need that refresher there. So cos is equal to adjacent over hypotenuse. The adjacent side is 4, the hypotenuse is 5. Boom, we're done, right? X is equal to 4/5. Okay, so both of them very, very quick. Okay, y is equal to the sine of theta. And how can we associate these together? X is cos, y is sine. We're going to be doing that a lot this unit. Alphabetically, C comes before S. If you can think of some X is cos, y is sine, after a while it'll just click in with you. And sine is opposite over adjacent, or opposite over hypotenuse. Opposite over hypotenuse. The opposite side is 3, and the hypotenuse is 5. So boom, we're done, 3 over 5. Okay, so whichever side you want to get to, here is your answer. Cha-ching. Okay, we are almost done. We're getting there, folks. The last example for today. The point P theta lies on the intersection of the unit circle and a line joining to the origin to the point -3, 6. Find the coordinates of P theta. Now, it's exactly the same as our previous question, except that we have picked a new quadrant. And I cannot draw a vertical line very well. So here is our -3, 6. So I guess here is our point way over here, okay, and we have a line that comes down over there, right? I just got to try this over again. That was just pathetic. Okay, let's try this one more time. Sorry, folks at home. Okay, so I think if I line up my pad a little bit better. Okay, so here is a still not great. Okay, so we have this -3, 6 would be way over there, right? And then we're going to have a line that goes out there, right? And comes over there. And that's going to hit our unit circle somewhere over here. Smaller unit circle over there. And this is our point, P. And we have to figure out what is the x value and the y value. So again, we can do our similar triangles here. So if we think about our similar triangles, we have, and I'll try to draw the correct orientation. So here is our, this is our x side here, this is our y side here, and this is our 1 that we want to find out. And then we have our 3 and then 6 like this. Now, when you're drawing your triangles, you might think, oh, it's -3. How am I going to deal with that? So I would right away in the beginning when you're looking at this think, okay, it's quadrant number 2. Okay, so you're going to anticipate when you're done that your answer, your x value will be negative and your y value is positive. There's nothing wrong with keeping a -3 in here for now, right? And putting the 6 over there, so it's going to work out mathematically the same. But sometimes when you're doing these questions, depending on the variation on it, sometimes you're going to have to remember that x comes out negative because you'll be doing a square root and you don't know whether it'll be either both positive or negative or just negative. But if you keep track of which quadrant you're working in, then you're going to anticipate what the values will be. Okay, so we have -3 and 6. So the other piece is, remember to we're going to have to find the hypotenuse. In the previous question, it was easy. It was a 3, 4, 5 triangle. So in this case, it's not. It's a -3 and a 6, right? And I'm not going to say x squared just because it sort of we get confused with this is the x we're trying to find. So why don't we call this one c squared, because that's what we've often used for a hypotenuse. -3 squared is 9. Plus 36 squared is 36 equals c squared. 9 plus 36 is equal to 45 equals c squared. So c is going to be equal to the square root of 45. Now we can leave that as 45, and I know we haven't done too much work with radicals yet, but we can simplify this root 45. So if you think of what's a square, like 2, 4, 9, 16, 25, 36, those numbers, what's a square that's a factor of 45? So in this case, 9 is a factor. So 9 times 5. So first step is I'm going to break that root 45 into two pieces, root 9 times root 5. And then I'm going to say root 9 is the same thing as 3. Okay, so in terms of proper math, this is the same as 3 root 5, but this is a better answer because we're going to be able to simplify things later on. So we're going to see that in a second. Okay, so let's go back over here and let's think about our the similar triangles method. So x over 1 is equal to, oh, this is 3 root 5 over here, 3 root 5. X over 1 is equal to -3 over 3 root 5, or another way to say it, here's my angle. Feels a little weird because the angle's over there, on the right. So cos is equal to the adjacent over the hypotenuse. Okay, so regardless of which way you think of it, as x over 1 is equal to -3 over 3 root 5, or to say the cos of the angle is equal to -3 over 3 root 5, the math is -3 over 3 root 5. And can we reduce that? You betcha. We got a 3 in the numerator and the denominator. We're going to divide that out, so we'll get -1 over root 5. Okay. If you want to, I would accept this as an answer. That's great. You can also rationalize the denominator. So you say, how am I going to do that? I multiply the top and the bottom by root 5, so I'm not changing it. I'm multiplying by something equals to 1, so I get -root 5 over 5. Okay, so this is a good answer, and this is a even better answer, but both are correct. Now our y value is going to be equal to, you can think of y over 1 is equal to 6 over 3 root 5. Or if you hopefully you're getting comfortable with, you can also say y is equal to the sine of the angle. So that's the opposite over the hypotenuse, 6 over 3 root 5. So that's going to be equal to 2 over root 5. Or similarly, if I rationalize the denominator, then I will get 2 root 5 over 5. Okay, so let's, and then we'll say, hey, I'm in quadrant number 2, so how are things going? Yeah, my x is negative, perfect. My y is positive, that's what I want. So here is my ordered pair. I'll have negative 5, or negative root 5 over 5, comma, 2 root 5 over 5. And there is my answer, and please enjoy the questions. We're going to leave that last one for later, but do at the end of 4.2, so that's starting on page 186, do questions 2 to 6. Thank you.